All right, so we come to 2.6 symmetry. Okay, so we want to check if a graph is symmetric. We have three areas to check for that: about x-axis, about y-axis, and about the origin. Okay, so the first thing we are dealing with now is to check if the graph is symmetric about x-axis, y-axis rather, if the graph is symmetric about y-axis. Okay, it is symmetric about the y-axis if and only if this value, don't forget we have minus x, y, that value lies on the same graph with this value. Okay, so when we are testing for symmetry about y-axis, we are changing x to a negative x, and we want to see if that graph lies, if this one lies on the same graph of this one. So we are replacing x with negative x. That is how to test if it is symmetry about y-axis. We are replacing x with negative x. Okay. So if we replace x with negative x and the equation is still the same, then it is symmetry about y-axis. Then we have obtained symmetry about the y-axis. Okay. Now, for example, we have this equation given to us, y equals to s squared. We want to test if this is symmetry about the y-axis. Don't forget, when you want to test for symmetry about the y-axis, you just replace x with negative x. Okay, so if I replace x with negative x, I perform the same operation that is in the original equation. I'm going to be having x squared, the same equation. So you see, this is the same equation as was given to me. Okay, that shows that this equation given to me is symmetric about the what? About the y-axis. It's symmetric about the y-axis. Okay, that's why you see the graph of that is given as this. This is x, this is y. You see the graph. Okay. Okay, you see that graph? So whatever we have for our x here and negative x here, it gives us the same value of y. The same value of y. That is symmetry about the y-axis. Okay. Now we want to talk about symmetry about the x-axis. So if you want to get or you want to determine symmetry about the x-axis, you also change y, okay, from positive to negative y. So when we have that that lies on the graph, if the point of this lies on the graph of this also, then that is symmetry about the x-axis. And we replace y by negative y in the equation. We replace y by negative y. Okay? All right. Of course, the one we have before, if we want to test if it is, if we want to determine if it is symmetry about the y-axis, change this to negative. Then we have negative y is equals to, now solve for y again. This will now become negative. So you can see that this is not symmetry about the about the x-axis. It's not symmetry about the x-axis. Okay, because it's not giving us the same equation as we have here. Okay, but let's test this one. X equals to y squared minus 5. Now we want to test if it is symmetry about the x-axis. That means we are changing y to negative y. We have x equals to negative y then square minus 5. So by the time we solve that, because this is a even power, then we have y squared minus 5, which is the same equation as we are given. So that shows that it is symmetry about the y-axis. It is symmetric, x-axis rather. It is symmetric about the x-axis. Okay. Now the third one is to test if it is symmetry about the origin. So this only happens if and only if we change x to negative x. So this value of negative x and y lies on the graph when it is positive x and y. Okay, that is symmetry about the origin. That means whenever we are testing for symmetry about the origin, we are replacing x with negative x and y with negative y. And then we solve for that. Okay, so for example, the one we picked before, y equals to s squared. If you want to test for symmetry about the origin, testing for symmetry about the origin, So we replace these with negative y. We also replace these with negative x. Okay, take note that whenever we are replacing these that has a power, you don't just put the negative. You don't do like this. You don't just put the negative out. It's part of the x. So an x is raised to power. So you must put it inside that power also for you to be correct in your workings. Okay, so if we have this now, this becomes negative y equals to s squared. All right, so making y the subject now, we have y equals to negative. So we see it is not symmetry about the origin. It is not symmetry about the origin. So to find symmetry about the origin, you are just replacing x with a negative x and y with a negative y, and you test for that. Okay. All right, so we also have another symmetry. We say it is symmetry about the line x equals to y, about the line x equals to y. Okay, this symmetry occurs if and only if y comma x lies on the graph when x comma y does. Okay, so what we are doing here is just we are interchanging x and y. Don't forget when we started the graph, we said this is an order period. Okay, and this is not equals to this. Okay, is an ordered pair. But when we have a graph that the value x, y lies on the graph as yx does, then that is now symmetry. Symmetry about the line y equals to x. Symmetry about the line y equals to x. Okay. All right, so if you have this equation or this example, we want to test if this is symmetry. Which symmetry is this one? Okay. Example. Test for symmetry of this function. Test for symmetry of this function, f of x equals to 1 over x. Okay, we want to test for which of the symmetry is this. Okay. To test for that, we can equate f of x with a y. We say this equals to this. All right. First, let's test for symmetry about x-axis. symmetry about x-axis. To test for symmetry about x-axis, what do? We equate, we find when y is negative. Okay, so we replace y with negative y. Okay, we replace y with negative y. Then we have negative y equals to 1 over x. And then that implies that y equals to negative 1 over x. Okay, so we can see that this is not symmetry about the x-axis. So no symmetry about x-axis, no symmetry. Okay, that is that one. Let's test for the second one, symmetry about y-axis. Symmetry about y-axis. Okay, here what do? We replace x with a negative x. Replace x with a negative x. Okay, so we have there y equals to 1 over negative x. This is the same thing as y equals to negative 1 over x. Okay. Negative at the denominator is the same thing as negative at the numerator. And even the same thing as negative in the middle. So if you have minus 1 over x, it's still the same thing as 1 over minus x. It's still the same thing as minus 1 over x. I mean minus here, minus something in the middle, okay? It's still the same thing. All right, so there is no symmetry here, no symmetry. All right, okay, again, let's now find symmetry about the origin. Symmetry about origin, number 3, symmetry about origin. In symmetry about origin, we replace x with negative x, y with negative y. Okay, so let's do that. From the equation, we now have minus y equals to 1 over minus x. All right, so multiplying both sides by negative, we have y equals to 1 over x. And that is the original equation given to us. That is the original equation given to us. So we see there is symmetry about the origin. 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 Okay. Now we can also test for symmetry about y equals to x. Number 4 now, symmetry y equals to x. Okay, so that means what we are doing is that we are just replacing x with y. Okay, about the line y equals to x. So that means y equals to 1 over x. We replace x with y. We replace x with y. We replace y with x. So when this is now x equals to now, this is now y. We replace that with that. Okay, if you solve for y here again to see if we are going to get the original one, we are going to have xy equals to 1. And then we are going to have, this implies that y equals to 1 over x. Okay, so it shows that it's also symmetry about a line, y x equals to y. Okay.